This lesson is for PPF 301 on parallel lines. Now our focus skill for today is to understand the relationship between angles in parallel lines. Let's begin with some very important vocabulary terms. First, we're going to draw an angle with a vertex B. Now you may have seen angles in previous math classes, but I just want to go over these terms with you. So I'm going to draw in an angle here. Now this angle consists of two parts. These are the sides here of the angle, and these are called rays. Okay, so a ray is like a line segment, but at one end we show an arrow here that it goes on forever and forever. So I could continue to draw out this angle here as long as I want, because it's going to go forever and forever since it's a ray. Now the rays both have the same initial point, so this point here is a point that they share in common, and that's called the vertex. Now in this case they ask us to draw a vertex B, so I'm going to label that as a B. So we want to make sure that that's always a capital letter whenever we are given a point. Okay, next up I want to make sure we go over some really important vocabulary terms for this particular skill. Now there's three different ways that we can classify an angle. We can say that it's an obtuse angle, an acute angle, or a right angle. So an obtuse angle is an angle whose measure is between 90 degrees and 180 degrees. So it's over 90 degrees, but it's less than 180 degrees. Now 180 degrees would be a straight line. Okay, that represents 180 degrees here. Now an acute angle is an angle whose measure is between 0 and 90 degrees. So if x is between 0 degrees and 90 degrees, we call that an acute angle. And finally we have a right angle. So a right angle is an angle whose measure is exactly 90 degrees. So if x here is exactly 90 degrees, then we call this a right angle. And you can see I drew in this box here. Now that little box that I'm drawing now in red, that shows that these two rays here, so this box here shows that the two rays here intersect at a 90-degree angle. We also use the term perpendicular to describe that. So whenever you see the word perpendicular, sometimes we use that little box here to show that. So this is what shows that something is going to be a right angle. If you don't see that box, you can't assume, even if it looks like it's a right angle, don't assume that it's a right angle unless you see that box. Now we're going to be asked to name specific angles. So when we name an angle, there's actually three different ways that we can name an angle. We're also going to decide in these problems if the angle appears to be acute, obtuse, or right. So let's start with this first example. Whenever you name an angle, one of the ways that you can name that angle is by the vertex. Okay, so by our vertex. So in this case, I'm going to call this angle A. Now if you look at the symbol that I'm using, that's supposed to show like a little angle, but sometimes that gets confused with L, so I like to show that little symbol going through it just to show angle. Now in your textbook they might show it like this or like that, so it just depends. So I like to just put the little symbol through it so that people don't confuse that with an L. Okay, now that's one way. So I won't name this angle B because that is not the vertex. Clearly that is not the vertex. It has to be the point where they share in common, the vertex. So we don't want to name this angle B. That doesn't work. We can also though name it by the three letters here that appear on this angle. Okay, so you can show by these two other points. Each one has to be on one of the rays. So I have a point on the ray here and another point on the ray here. Now I can name this, and the order is important. I'll talk about the order in a second, but the second way that I can name this is angle BAC. Okay, so angle BAC. And finally, the third way is going to be angle CAB. Now the order is really, really important here, the way I named these. If you notice, I went from B to A and then to C. That's the first example that I did. Then in the second example, I started at point C, then I went to A, then I went to B. That's okay to do. The only thing you don't want to do is go from A to B to C. Notice I'm not really following the angle at all. Also, you wouldn't want to go from A to C to B, right? That's again not following the angle. So whenever you name an angle, if you notice, the vertex will always appear in the middle. If you go in whatever order you decide, if you started here, you'd have to go to the vertex next, and then you would go to that angle, the point C here on the other ray. So you always want to make sure that the vertex is in the middle. And finally, it asks us to classify if it appears to be acute, obtuse, or right. So I'm going to say it's not a right angle, and that's because I don't see a little box here. There's no symbol. And I'm going to also assume that it's not acute because it doesn't appear to be a smaller angle, less than 90 degrees. So I'm going to go with obtuse here because it looks to me like it's bigger than 90 degrees. Now in the second problem, we have an angle, and if I want to name the angle, remember I can do it by its vertex, so I'm going to call that angle Q. This is the vertex. If I want to name it again, I could call this angle P, Q, R. So I go in order, P, then Q, then R. I could also call this angle R, Q, P. So R, then Q, then P. So those are the three ways that I can name this angle. Now this angle appears to be a right angle. That's because I see that little box here. So I'm going to assume that that means that it's a right angle. And finally, in our last example, I can name this angle V. But I can also name this angle TVO. So T, then V, then O. And I can also name this angle OVT. So in the other order here, O, then V, then T. So I just want to point out, again, that you're seeing V, the vertex, in the middle. And over here in the previous problem, we also see Q, the vertex, in the middle as well. And then finally, I'm going to classify this as an acute angle because it looks to me like it is less than 90 degrees. So that's going to be an acute angle. So I would like you guys to try the next couple problems here. Make sure you name the angle 3 different ways and then decide if it appears to be acute, obtuse, or right. Okay, we have a couple more vocabulary terms to go over. Now these might seem familiar to you because you might have talked about them in a previous math class. But the word complementary is a word often used when we talk about two angle measures. So two angles are complementary to one another if the sum of their angle measures is 90 degrees. So if we were to take two angles and if we add those measures up, we end up with 90 degrees, we call that complementary. The next word is supplementary. If two angles are supplementary to one another, then the sum of their angle measures is going to be 180 degrees. Okay. Now, a lot of students will confuse the words complementary and supplementary, so I want to help you try to remember these. If you look at the word that it starts with, or the letter that it starts with, here we have a C and here we have an S. Remember, 90, that letter, or that number, comes before 180 degrees, just like C comes before S in the alphabet. So that's how I actually remember it too. I think about what comes first, complementary. The C comes before S. And 90 comes before 180. So that's how I group those together. Okay, let's try to fill in the blank here in the next couple problems. So the first sentence says, if the measure of angle A is 24. So we see this little symbol. That means the measure of angle A. So it's just an abbreviation for measure. So they're giving us the angle measure here of angle A. And they also say that angle B is 66 degrees. Well, since 24 and 66 will add up to 90 degrees, we say that A and B are complementary angles. Now, angle C, that's measure, is 37 degrees, and angle D's measure is 143 degrees. If we add those together, we end up with 180 degrees. So C and D are considered supplementary angles. All right, let's try to fill in this table here. Now in the table, we are given an angle measure. So here I have an angle measure of 24 degrees. I want to find the complement to this angle as well as the supplement to this angle. So when I'm looking to find the complement, I want to take 90 degrees and subtract 24 degrees so I find what angle measure would be complementary to this 24 degree angle. So I end up with 66 degrees. This is saying that a 66 degree angle is complementary to a 24 degree angle. Okay. Now to find its supplement, I'm going to take 180 degrees and I'm going to subtract 24 degrees. Okay, this will give me 156 degrees. So this is saying that a 156 degree angle and a 24 degree angle are supplementary to one another. And you can always check these answers because 66 plus 24 has to equal 90 degrees if the angles are complementary to each other. And 156 plus 24 degrees has to add up to 180 degrees if these are supposed to be complementary to each other. Okay, so really what we're doing is solving somewhat of an equation here. It's a really basic equation, but for example, I'm going to set the equation up here. For angle 2, this is an 80 degree angle. If I take an angle measure, let's call it X, and I add 80 degrees to it, I should end up with 90 degrees if the angles are complementary to each other. So if I want to solve for X, I would subtract the 80, and I'm left with 10 degrees. So x would be 10 degrees. Now, I can also do a very similar equation when I try to find the supplement. If I take that angle measure, we'll call it x again, and I add 80 degrees, so this is the 80-degree angle here, I should end up with 180 degrees if these are supplementary to each other. So this time I'll subtract 80 degrees on both sides, so I end up with x equaling 100 degrees. So there's my answer for the supplement and the complement. So let's erase here. So I got x equals 10. And again, that came from just solving a little equation. Here I have x equals 100. So we're going to write this as 100 degrees and 10 degrees over here. Sorry, I'm going to drop the x because I didn't really have to solve an equation. I just set one up to make it easier for myself. So the answer isn't x equals, it's just this answer here, 10 degrees. Okay. All right, now in the next problem, I want to find an angle that is complementary to 163 degrees. The problem is, though, that this is already over over 90 degrees. So there is no complement. Okay, there's no angle measure that I can add to 163 that will give me 90 degrees. At least not one that would be a positive value, and we don't want to deal with negative angle measures here. So this cannot exist. Okay, so there will be none for this case. There are no complementary angles to 163 degrees. Now for the supplement, we're looking again for an angle, let's call it x, that when I add 163 degrees, I end up with 180 degrees. So if I subtract 163 here, I end up with 17. So this angle measure would have to be 17 degrees in order to be supplementary to a 163 degree angle. So 17 degrees, there is my answer. Okay, I'd like you guys to try the next few problems on your own, and then we're going to go to looking at some parallel lines and the angle relationships that we see in parallel lines. Okay, two lines that never intersect are called parallel lines. Now when you see a diagram of parallel lines, you're going to see two lines that look like they don't intersect, and then you'll see little arrows attached. So this shows that these lines are parallel to each other. Okay, so for example, if I saw a diagram like this. Now, right now, it doesn't look like they're supposed to intersect, but because it's a line, remember these can intersect at some point. Okay, the line extends infinitely in both directions, so they would intersect here. So this would definitely not be an example of parallel lines. But the reason why we also assume that it's not parallel is because we don't see these little symbols. Okay, now if we were to see those symbols in this particular diagram, then even though that line looks like it's going to hit, it's not supposed to. So we might want to redraw it a little bit better, like this, to show that those are parallel lines to one another. So we always look for these little arrows, and sometimes they'll be double arrows like this to show that the lines are parallel to one another, unless they specifically state that the lines are parallel. Now there are many different angle relationships that occur when two lines that are parallel are intersected by a third line. So in this diagram here, we see that lines S and T are parallel. So it's missing the little arrows, but it tells us specifically that S and T are parallel. So I'm going to draw those little arrows in. So here's line S parallel to line T. Then we have a third line that's cutting through those two lines. We call that line a transversal. Okay, I'm just going to refer to it as a transversal from here on out. It's not that important for you to memorize that vocabulary term, but just so that you know what I'm talking about, I'm going to use that word transversal. So here a transversal is cutting across both lines S and T. Now because it's cutting across parallel lines, there are some special relationships that occur. Angle 1 and angle 2, these guys will always add up to 180 degrees. See how we form a straight line here? Okay, so we have a pair of angles that add up to 180 degrees. So the measure of angle 1 plus the measure of angle 2 adds up to 180 degrees. We will also see that same angle relationship here between angles 3 and 4. See how, again, you have a straight line involving angles 3 and 4. So angle 3 plus angle 4, those measures add up to 180 degrees as well. Now, 5 and 6, the measure of angle 5 and the measure of angle 6 also forms that straight line here. We call these linear pairs. So each one of these so far that I've gone through, angles 1 and 2, are called linear pairs. Again, a vocabulary term that will come in handy to know, so I might refer to this every once in a while. Angles 7 and 8, these are also called linear pairs, and they form that straight angle here, so they're going to add up to 180 degrees as well. If we look at angles 1 and 3, look at that. That also forms 180 degrees. We get that straight line, and these are linear pairs as well. So if we go through here, angles 2 and 4, they also appear to be forming a straight line, so that's 180 degrees as well. Those are linear pairs. 5 and 7, another linear pair here. We have those two angles adding up to 180 degrees as well. And finally, we're supposed to fill in the blank here for angles 6 and 8. So if we add the measure of angle 6 plus the measure of angle 8, what do you know? We also get 180 degrees. So basically what I'm trying to show you is that whenever you see two angles and they are directly next to each other and they form a straight line, those angles will always add up to 180 degrees. Okay. Now we also get a couple more relationships that I want to talk about, especially this next term in this bubble here, congruent angles. All right, so here's another very important vocabulary term. Congruent angles are two angles that have the exact same angle measure. Okay, instead of saying equal angles, we call them congruent angles. Really important term. You're going to hear it a lot in geometry next year. Now, in this particular example of the diagram, we have lines S and T, which are parallel, and they are cut by a third line here that runs through both S and T. So it intersects both S and T. Now, because it's intersecting parallel lines, there's a few angle relationships here that are really important. We create some congruent angles. Now, angle 1 is going to be congruent to the angle right across from it. So the measure of angle 1 is going to be equal to the measure of angle 4. Okay, this is another term that I'm going to write off to the side. These are called vertical angles. Angles that are directly across from one another. Now, some students will get confused and they think that these two angles are directly across from one another, but it's got to be in this relationship here, directly across like that. So it kind of forms like an X. This angle is congruent to this angle. Okay. Now, likewise, angle 2, since these are directly across from each other, angle 2 is going to be congruent to angle 3. Okay. Those are again a pair of vertical angles. So I can fill out the measure of angle 2 is equal to the measure of angle 3. Okay. Now let's go back to angle 1. There are a couple more relationships where angle 1 is going to be congruent to another angle. Angle 1 is also congruent, so not just 4, but it's also congruent to angle 5. Okay, so it's congruent to angle 5. Remember though, we just said that angles that are directly across from each other have to be equal. Okay, so if angle 1 is congruent to angle 5, and angle 5 here is congruent to angle 8, then angle 1 is also congruent to the angle on the outside here as well. So let me erase because it's kind of getting a little messy. So angle 1 here is congruent also to angle 8, so their measures are the same. So when you're looking at this particular angle here, so the angle, and I like to think of this as the top left, this would be the top right, this would be the bottom right, and the bottom left. So just in terms of what's on top, so here's kind of like the separating line. Here's another separating line. Here's the top right angle, the top left angle, the bottom left angle, and the bottom right angle. Okay. Now we repeat a very similar looking portion of the diagram below. So here would be the top left, the top right, the bottom right, and the bottom left. Right. Those angles are in those spots. So angle 1 is congruent, and it has an equal measure to the angle that's in the exact same position as it. So here's top left and another top left. Now it's also equal to the angle that's opposite of that top left angle down here, angle 5. So it's also equal to the one on the outside, okay, on the outside, on the opposite side. So here's the outer edge. If we think of this as the outside here and this is the inside. So here's another outside. Here's inside the parallel lines. Let's do the inside the parallel lines is blue. So everything that's marked in red would be outside. I got a lot of stuff in red, sorry, let me erase. Let's do a different color. Let's do purple. So everything here in purple and over here in purple would be considered the outside part, okay? So just trying to visualize that with you. So angle 1 is equal to the angle that's on the outside, opposite side though. So this is top left, this is bottom right, okay? So those are also equal to each other. Now, if we go around, let's go back to now angle 2. We already said that angle 2 is equal to angle 3. But because these lines are parallel and they're cut by a transversal, so that line here is called that transversal again, this is going to be equal and congruent to the angle here. So angle 2 is congruent to angle 6. So this is in the top right. This one is also in the top right. So it occupies the same position. Okay, so its angle is equal to, the angle is congruent to angle 6 as well. So the measures here are both equal. Now, opposite the 6 is this 7. And remember, 6 and 7 have to be equal because they are, these are called vertical angles. Okay, so 6 and 7 are equal, which means angle 2 is also equal to angle 7. Okay, and again, you're seeing the same kind of relationship. See how this is on the top right? Well, this is the bottom left. So it's total opposites, right? In terms of one is on the, they're both on the outside. So here's the outside portion of your diagram. But one's on the left side and one's on the right side. So 2 and 7 are going to be congruent and measures are equal to each other. Now let's look at angle 3. Angle 3 is going to be congruent to angle 7. This is in the bottom left. This is also in the bottom left. So angle 3 is congruent to angle 7. Now, angle 7 is congruent to angle 6. So the measure of angle 3 is also equal to the measure of angle 6. And back up here, angle 3 is also equal to angle 2. Okay, so we're just seeing basically repetitive relationships. I just want to fill in the blank one last time here for angle 4. Okay, now angle 4 is vertical angles with angle 1. So these measures have to be the same. So measure of angle 1 is equal to measure of angle 4. Now angle 4 is in the bottom right here. And in this angle, these pairs here, 8 is also in the bottom right. So 4 and 8 are going to be equal to one another, their measures. And then finally 8 is also equal to angle 5. If 8 and 5 are equal to one another, then 4 and 5 must have equal angle measures as well. Okay, so there's all of the different relationships that you're going to see with congruent angles. So angles that have the same exact measure. And then remember, all of the angles I already erased here. Sorry, I erased all of that work here. But these angles here would have to be adding up to 180 degrees because they form that straight line. So we're looking for those kind of relationships, okay? Now it's kind of a lot to take in, but basically that's what you're looking for. I want you to try to fill in these blanks here. You've got lots of options for filling in each of these. Here in the first one, we're just trying to show what two angles add up to 180 degrees with angle 5. So you just pick one other angle that'll add up to 180 degrees. And then in problems 2 and 3, you're finding an angle that is exactly the same measure as angle 7 and an angle that is exactly the same measure here as angle 6. So there's lots of options. As you saw in that table above, we filled out so many different options. Then you're going to do the same problems all over again. This time you're going to use a different angle. So this is just trying to get you to show that there's not just one answer. There's lots of relationships where angles can be congruent to each other. Okay? All right, that's the end of the lesson. So go ahead and get to work, and then we'll check in your notes.